Hello, good morning, and you are very welcome to this morning's IMR webinar, AI in Action, Applications of Generative AI in Manufacturing. This is quite the hot topic at the moment and has certainly captured the curiosity of the manufacturing industry, judging by the number of registrations and attendees we have this morning. And we're here to demystify and hopefully inspire innovation with generative AI. And when I say we, of course, I mean our expert presenter this morning, Carlos Garcia, IMR's Head of AI Strategy. Carlos has over 2 decades of experience and a PhD in AI applied to manufacturing. As the Head of AI Strategy in IMR, he's at the forefront of pushing the boundaries of efficiency and sustainability in manufacturing. So if you're curious about how AI can revolutionize your work, or if you're just a tech enthusiast, you're in the right place, as Carlos will be diving into the world of large language models, the likes of ChatGPT, Gemini, Mistral, and Copilot. These aren't just fancy buzzwords. These are transforming how we think about manufacturing processes, from data analytics to quality control. During the presentation, if you have any questions, use the chat question and answers function, which is on the bottom of your screen, and we'll get to them at the end. So now, without further ado, let's give a warm virtual welcome to Carlos Garcia. Carlos, the stage is all yours.
Thank you very much, Gary, for the introduction, and thank you for your work managing these webinars. It's always a pleasure being here. So a very important task that we do at IMR for me is to demystify new technologies and to assist companies to understand the potential value and applications that they could have. And today we are going to focus on the potential of generative AI and large language models. These large language models, including systems like ChatGPT, Gemini, Copilot, or open source alternatives like Llama 2 or Mistral, certainly are revolutionizing tasks such as email composition, software development. But at the same time, there is a lot of expectations and hype around these technologies. And today, my aim is to provide a balanced view of these technologies in the realm of manufacturing. I like to start these discussions with this paragraph from Plato, written 24 centuries ago. It's from the Phaedrus Dialogue. Here, Plato is discussing this new invention, this new innovation of the written characters, that until then, language was just spoken. And he is saying that this discovery of written language will create forgetfulness, will give not truth, but only the semblance of it, and that they will appear to be omniscient and will generally know nothing and having the show of wisdom without the reality. Besides the fact that innovations have always been a hot topic and contested, as we can see here, there are a lot of interesting questions relative to large language models here. Like, are they really understanding anything, or is just a semblance of truth they give us? So I will start with a brief history and potential of generative AI. The picture you can see here was quite obviously created by one of these systems. And you can already see some of the challenges they have, as they currently don't understand that some of those pixels on the screen are actually text, are actually words. So it's creating some text without any meaning at all. Right? This generative AI is not new. It wasn't created in 2022. We have had systems like the Lisa chatbot, for example, in the 60s, or generative adversarial networks that are able to create new content. And this creation of new content, that's the main difference between this generative AI and, let's call it, more traditional AI. Until now, AI was mostly used to look at past data, historical data, and find patterns in that data. So we can answer questions like, was there any anomaly in this sensor data from my machines? Or prediction, can I predict if this machine is going to fail and when? But generative AI is about creating new content. It's about creating new text, new images, or new videos, for example. And despite, for all of us that have been working with AI for a time, we know this concept of AI winters. Those were times of inflated expectations about what artificial intelligence we could do. And when we realized it wasn't going to change everything, there was a period of decline on funding and research. Am I saying that this can be an option, a winter again with generative AI? No. already these generative AI models are showing a lot of actual useful use cases. So I don't think there will be a winter here, but it's true that there is a lot of expectations about them. And there is a lot of talking about artificial general intelligence now. So can these systems get up to this human intelligence level or not? So we need to be careful about this and not fall for the hype. This will not be a deep dive technical introduction to LLMs. I will not talk about how they actually work. If you are interested, I can recommend this excellent video from Andre Karpathy's on YouTube. It's called Intro to LLMs. You can check it. It's really good. A little bit outdated by now because things are changing so fast, but it's still very good. So let's look a little bit about the particularities of manufacturing. This is about application of generative AI to manufacturing. So we all know that the manufacturing sector has been traditionally quite risk averted or cautious with new technologies because of the cost and risk. And the last reports I've seen show this to be the case again with generative AI, which is understandable because it's not the same thing to have a generative AI system in the cloud creating videos, and then if you have a prompting problem with it, like it happened, you just take it down for a few days, and then you just put it up again, than if you use one of these systems in production. Because in production, as we all know, it can have a very clear implications and disruptions. Those disruptions can apply to workforce as well. When we introduce generative AI, these have very clear uses for not only for operational, but also for your HR, your finance departments. But this will necessitate jobs to evolve and will require people to adapt and to use these new tools. And this can lead to resistance from employees fearing job loss or the need to acquire new skills. Data security is always also an important factor in manufacturing. Manufacturing companies have their own proprietary data that they don't want to share with anyone. Using a large language model can open holes in that. So we need to be very careful about how we use these large language models in manufacturing. And finally, I wanted to talk about tailored AI. What I mean is that in manufacturing, in our experience, a one-size-fits-all approach usually doesn't work. And these models give us the ability to fine-tune, let's say, to retrain, if you want, AI models with data that is unique to the company. And that can lead to more efficient operations. But here we can focus on developing new AI solutions that are customized to address the unique challenges of your company and your objectives. So this is a very interesting point. So moving into what potential applications we can have in manufacturing. This whole slide was created by Copilot 365. I asked the question, write a slide or create a slide with potential applications of large language models in manufacturing, and it came up with this. Interestingly enough, if you look at the first bullet there, the analyzing machine logs, it actually took that info from IMR own documents because we have been working with large language models in IMR to analyze those logs. So he found documents related to our work, and he put that in the first position, while the rest of them are probably from its own training data or from the web using retrieval augmented generation or RAG. So if we look at what it says it can do for manufacturing, well, extracting insights, optimizing supply chain, improve product quality, predict machine failures, reduce downtime, so the whole lot, right? And this is where we need to step in and say, okay, maybe this is true to some extent, but is this really better than other alternatives that we already have in manufacturing or not? So the way to look at that is, instead of looking at how they work internally, I think it's better to start by what do we know they are good at and what not that good. So from the good things that they do is obviously the natural language understanding and generation. They are great at interpreting and generating human-like text. So this makes them very useful for things like chatbots or voice assistants that maybe can answer questions not only in your customer relationships, but also in the workers on the factory floor. And this can be especially helpful for things like, for example, complex machinery or frequently changing procedures. Number two is text summarization. They can condense long pieces of text into shorter summaries, keeping the relevant details. So in this regard, LLMs can be used to summarize long reports generated by machines or by sensors. And they, in theory, they identify trends or anomalies in that data. Number three is pattern recognition in text, which could be useful in applications like sentiment analysis, for example, useful with customer support and text classification. And finally, programming assistance. Obviously, they are already making a huge change in how we code and program. So in summary, LLMs excel at summarizing large volumes of text, classifying and mining data, and generating new text. And you can do it in a user-specified style, tone, or format. So this can be really useful. But at the same time, we know they are not good at everything. The first point here for me is the common sense reasoning that they lack. So common sense is a very human capability that's grounded in how we interact with the world. And we have 5 types of sensors, and we are interacting with the world with those 5 types of sensors constantly and learning from that. That's an ability that large language models don't have, but they are very good at fool us to believe they do, because they speak our language, they answer our questions. But we need to be careful with that and don't think that they understand or they can provide good answers always. It's easy to fall there, but they lack this kind of reasoning. Working memory, what I mean by working memory is that every time you interact with one of the systems, it's like a separate event. They don't remember what happened before. This is related to the concept is context length in these large language models, which is basically how much text they can use and consider in one interaction with them. Now, it is true that this is advancing very, very quickly. Last time I heard from Gemini 1.5, the last model is not available yet, but they are working with a model with 1 million tokens. That means that it can work with more or less 800,000 words, which is a huge advance from the current, let's say, 4,000 to 80,000, more or less, depending on the model. But it's something that is advancing very, very rapidly. Then bias and reliability. So the bias get from the training data they get. If that training data is biased, then they will be biased. And reliability, each time you work with one of these models, you read a small letter there and it says, be careful, AI can make mistakes. So at what point can we say, or do we say no in manufacturing because the potential of error? That's something to be aware of and to be investigated. And finally, they are bad at understanding non-text data. For example, math. They are very bad at math. They can tell you how much is 2 + 2 because I have read that many, many times in their training data. But if you ask a large language model a more difficult arithmetical operation, they don't know. Now, it's true that they can use external tools to do that. And it is true that there is a lot of research in what we call multimodal AI, which is training these models not only with text, but also with images, with videos, with sound. So this is changing very, very quickly. So knowing this, and looking at what we can do with these models, we need to separate clearly between the open source and closed models. So the closed models are your usual OpenAI, Google, Microsoft, Claude, for example. And these models are usually more performant than the open source models that you can just install and modify as you want. But it is also true that the open source models are advancing very, very quickly. And some people think that this is really the future of large language models, the open source models. So that's something to consider. Open source large language models may have also limited functionality compared to closed LLM models. But with open source, you can install it and fine-tune it on your company-owned data, which is a big plus that is being investigated in many places. So with this introduction, let's look at actual potential applications in manufacturing. And see, I'm always saying potential applications, right? So let's start following Copilot list of potential applications. Let's start with this analyzing machine logs. So what you see on the left is an example we have in our facilities in Mullingar. This is a JSON file from one demonstrator of scheduling, actually. And you can have messages like this, like a few every second, for example. That would be common. So that's impossible for a human to go through. But for an LLM, it's easy to go through that and actually give you what is going on, or even if there are things that doesn't look good, if there is some anomaly. And you have an example of one of our large language models in Mullingar telling us some information about that log. Number two, it's the use of these models as a data analytics expert. So everyone now can do data analysis from multiple sources without analytics qualification. So these large language models can aggregate data from your ERP, your MES, and other sources of data to create insights or dashboards like this one. This one example is a simple one. It's time series data from one sensor, a humidity sensor. Just by natural language, anyone can tell him, create a model to find anomalies for me. This is a fault detection algorithm that is creating. So basically, it's using Python to use some statistical analysis to create that and then create a dashboard for you. So all of this, anyone without any AI or statistical background can do it, which is a huge difference with previous artificial intelligence. Now, careful with data security, as always. Data inputs needs to be accurate and up to date. And the outputs always need to be validated and monitored. Another use case would be to extract information from diagrams. The diagram you see here is a SysML diagram, systems modeling language, that we use to model complex systems. And you need to have some knowledge of how these diagrams work. You need to know why this is a dotted line or continuous, if the arrowhead is full or not. So you need to know. But you can use one large language model to upload an image like this and then ask, in this example, do minimum production costs depend on cycle time, for example? And it's, as you can see in the answer there, in this case, this is ChatGPT. ChatGPT-4, it's answering correctly that answer from that diagram. So even if you know how to look at those diagrams, this can save time already, or you can use them even if you don't know what a SysML diagram is. Number 4 related to this one is working with technical manuals. In this example here, I have 2 different manuals of 2 machines that we have in Mullingar, 2 additive manufacturing machines. These are hefty manuals. So LLMs can help with improved troubleshooting because they can analyze these technical manuals and maintenance logs to assist with diagnosing issues or providing step-by-step troubleshooting guidance. Or can be used to retrain personnel. Suppose you are moving from the machine on the left and now you are moving to the machine on the right, and you need to learn how to use it. Your personnel needs to learn. These tools can help with that, to transition between machine models, because they can generate a tailored instruction and highlight differences in operation, for example. So that could speed up a lot this retraining. Or also the creation of ad hoc training docs. Can compile customized training documents for different groups of people in your organization to address specific needs. Number 5, we get to predictive maintenance, which is also always a hot topic. So let's start with this data CSV spreadsheet. You can see here, this was actually downloaded from Kaggle. It's 1,000 rows of 20 to 25 different variables taken from a compressor. It's open source, you can download it. And directly I uploaded the data CSV and I asked, what is the influence of the exhaust pulse condition on the compressor's efficiency? So the first thing it did is open this CSV and it correctly identified by the name what is each one of those variables there. And there are more than that. But it correctly identified what they mean. And then it went on to create an analysis using Python again. It created a statistical analysis to look at that influence. So it came up with different results. And in the summary, it says that the outlet pressure does not show a significant difference between the 2 conditions, etc. You can read that, but it's a good answer about the maintenance, how these variables are impacting the maintenance of this particular compressor. Is this better than alternatives that we have now? No, I wouldn't say that. I would say if you already have your predictive maintenance or your team working with your machine learning algorithms or statistical algorithms to work on this Probably they are better, but the ease of use of this, anyone using these large language models to provide a first answer very quickly, that's a huge capability that is there. Number 6, even I said that these models are proficient at language, and usually you don't think about them for images, but we were testing this in Mullingar. So we took several images with our microscope of some tools that we use in our CNC machines. So we tested this with ChatGPT-4. First, I uploaded this image here, and my only question was, what is this? And the answer from ChatGPT is, this appears to be a pencil tip, which, if you think about it, is not a bad reply. And many of us probably will say the same thing. This is a pencil tip. The interesting thing here is that then I told him, no, it's not a pencil tip. It's actually a tooling. It's a tool from a CNC. And just by saying that, the context of the information it had changed completely. And then the next answer was this one. So it brought all the knowledge it has. And once I said it's a tool, then created this answer here, which actually is quite good. It talks about the discoloration and that, yes, this tool has undergone some degree of wear. And the final one I want to discuss is robotics. There is a lot of research going on in robotics now. The video here is from a company called Covariant. I'm going to play it for a moment. So basically what is happening here is that they are using large language models to talk to the robots. Not only that, the robots can talk back to you. In this case, what is happening is that this robot at some point is not able to grasp something. So it's getting back to the user asking, hey, do you have any suggestions? I cannot get a good grasp. That's the LLM talking back. And then the user goes and says, move to 2 centimeters, blah. And then the robot understands that and can actually pick them up correctly and actually use that information for other interactions later, which is pretty amazing. Now, Covariant themselves in the webpage say that this is not commercial. This is still on research, and that there will be still a few months before this is commercial available. But still, I would say it's very, very impressive. So to summarize, first, it's clear that generative AI opens up many, many possibilities for manufacturing, not only for operations, but in every area of your company, because it's accessible to all. So they can drive innovation in every sector and every area of your company. But you need to be warned about incorrect outputs from flawed training data. This is always the case with these models. So how to monitor that in manufacturing? How to do that is something that we are investigating, right? How to monitor and be careful about these errors. And advice for everyone is to, since manufacturing, we are always lagging a little bit on that, but you can still look at other sectors like healthcare that are moving maybe faster than we are, and look for their applications of large language models and see how they can be applied to manufacturing. And large language models make mistakes. Always verify the results. And finally, there are many, many claims about AI's human-like reasoning and artificial general intelligence. From my point of view, these are still premature. Large language models like we have today will not get us there. And probably there will be something very different from large language models in the next few years. But now, yes, generative AI can have a lot of good applications for manufacturing. Just be careful about them and know that they cannot do everything. And even if they can, maybe not better than what we can do with other approaches. Thank you very much.